Hello students and welcome to another video. I'm your teacher Mr. Flint, and today we're going to be talking about percent error. Okay, and this refers to when we're working in the lab and we get some results and we don't know how our results compare to something that's more of a standard. So for example, if you go into the lab and you weigh some coal and you find out that that coal weighs a certain amount, because coal is basically just carbon atoms, and you find out that carbon weighs 13 grams for a certain amount, okay? And when you look at our periodic table, which is our standard, it's 12.01. So we were about 1 over what 12 is. So how off were we? What's our percentage that we were, how close were we to our number? So that's what percent error refers to. Okay, so now let's, and also too, before I forget, on the back of your periodic table, I do have this formula here. So you don't have to memorize it, you just have to know how to use it and apply it. So let's go through a couple examples. So it's on the back of the periodic table, a P table. Okay, your green one, it could be a different color, depends on the year that I made these tables. It'll change from year to year, but it's the one that I hand out in class. All right, now percentage error, I don't want to write out percentage error, so I'm just going to write dashes. Okay, that's what this refers to. All right, is a measure of how inaccurate a measurement is compared to a standard. Okay, and the formula we use is percent error is equal to your observed value. I'm going to put the minus the accepted value, and then we divide that from our accepted value. And then we multiply the whole thing by 100 because we want it to reflect a percentage. So let's do an example to illustrate how do we apply this formula. Okay, so our example is you measure the boiling point, I'm going to write boiling PT, okay, boiling point of ethyl alcohol to be 75 degrees centigrade. Okay, that's what you observed in the lab. You measured it out, you saw it started boiling, and you recorded the temperature at which it was doing that process. Okay, but in reality, it's actually 80 degrees. So you were off by 5 degrees. So there was some error in your instrumentation. It could have been you misreading it. There's a number of reasons it could be off, but based on the evidence that we've collected over for some standard, okay, we've determined it, it's going to be 80 degrees. Actually, the accepted, I'll say the accepted value is equal to 80 degrees Celsius. So how close were we percentage-wise? That's what we want to know. So what I'll do is 75 degrees C minus 80 degrees C, and I will divide that by 80 degrees C. I'll set it up just as I have up above. So I have 75 minus 80 divided by 80, and then I'm going to multiply that by 100. Okay, so if I type that in my calculator, let me pull this out so you can see. All right, I have 75 minus 80, and I divide that by 80. Okay, I get 0.0625, and then I multiply that by 100 because we want to make it that decimal percent. So I was a negative 6.25% off, so equal to a negative 6.25%. All right, but it's a negative. What does that mean? That means I was under 80, which reflects 75 is below 80. I mean, if you look at these numbers. So it's under by 6.25%. When it comes to these numbers, I really don't care to see it plus or minus. You can just kind of pretend that this is a positive number because it's just referring to, like, if this is the standard and you were down here, you're down by 6%. Or it could be up by 6%, but all that matters is you're off by 6% in one direction or the other. Negative means you're under. If it's positive, it means you're over by a certain percentage, okay? And it will depend on what you're doing in the lab that's going to give you those kinds of results. We'll do labs throughout the year where we're going to create a product, and we got to figure out how close were we to what our accepted value was. Okay, so this is just an example of percentage error, and you have some practice problems to work on as well. So this number is just showing you how close you were to being accurate. Okay, that's it. Thanks for watching. Till next time.